Hi everyone, it's Mrs. McInnes here. Welcome to lesson 4 of Similarity. So today we're going to be looking at reversing the similarity, so problem solving style questions, and then we'll also go on and look at a couple of past paper style questions for the similarity topic. So let's start off with looking at reversing the similarity. So this is all about working backwards to find a missing length, okay, when we know either the similar areas or the similar volumes. So we're working backwards, okay. So what we have to think about is what was the original process and what would the reverse process be. So if we have the two areas of our two shapes, what we do is we get our area scale factor and then we would square root that value to go back to find the length scale factor. And then in a sort of similar way, if we know the two volumes, we would find our volume scale factor. And then what we would do is we would cube root that value to go backwards to find the original length scale factor. So let's go ahead and try a couple of examples of this. So example 7, we have two objects below are mathematically similar and have dimensions that are shown. So the small shape here has an area of 4 centimetres squared and the length just at the bottom there is 3.5 centimetres. The larger shape has an area of 36 centimetres squared and we're being asked to find this length that's marked X. So we know the areas of both of these shapes, so we can use the area scale factor to work our way backwards to find X. So the first thing that we would need to do is write down our area scale factor. Now, because we are wanting to find the length of the larger shape, we're going to put the larger area on top. So 36 over 4. Okay, so big over small. So 36 divided by 4 gives us 9. Okay, so what we can do now is go backwards from this to find our enlargement scale factor, okay, because we're finding the length on the bigger shape of the two, which is why we put the bigger volume over the smaller volume. So we would square root the area scale factor, so the square root of 9 is 3. So that means our enlargement scale factor is 3. So to find side X, we would just simply then do 3 times the side that corresponds, so 3.5, which is going to give us 10.5 centimetres for that side that's missing X. Okay, let's try another example. This time we're going to look at some similar volumes. So here we have two waste paper bins, a smaller version with a volume of 5 and a missing height. The larger version has a volume of 40, the height is 45. So because we're finding the volume of the smaller bin, when we do our volume scale factor, we're going to put the small volume first, so 5 over 40, which simplifies down to 1 over 8. So then we would do the cube root of this value to get our scale factor for length. So our reduction scale factor, we would cube root that number, because in the original process you cube your RSF or ESF, we would cube root the value to go back the way. So the cube root of 1 over 8. So what we do is we say, what's the cube root of 1? So what do you cube to get 1? Well, that's just a 1. 1 times 1 times 1 is 1. What do you cube to get 8? Will that be a 2? 2 times 2 times 2 is 8. You would have a calculator likely for this question, but if it's non-calculator, that's how you would think about it. So our reduction scale factor is 1/2. So our height is going to be our scale factor times the length that corresponds with the missing length, so times that 45. So that's going to give us 22.5 centimetres for the height there. Okay. So now let's go on and look at some past paper questions and see what kind of question you could get in an exam or assessment situation. So here we have our first past paper question, and this question is from the 2015 paper 2, if anybody is interested, and that one was question 9 in the original exam paper. So here we have a flag at each hole in a golf course is coloured red and blue. And we're told the diagram represents the flag. So triangle QRT is the red section. So QRT, if you follow those letters round, that tells you that triangle there is the red section. And then it says PQTS represents the blue section. So if you follow those letters round, PQTS is that section there, that bit there is blue. So our triangles PRS, which is the big full triangle, if you follow those letters round, P to R to S, the big triangle, and then the smaller triangle, which is just the red bit, are similar triangles. The area of the triangle QRT, so the red one, is 400 centimetres squared. And we want to calculate the area of PQTS, just the blue section. So first thing we need to think about is, what is our strategy? What's the strategy to find that blue section? Well, what we would do is we would do the large triangle, and then we would do just the wee red triangle and subtract that away, and that will leave behind the blue section. Okay, so really what we're finding here is the area of the large full triangle. So what I'm going to do first is I'm going to separate out my two triangles from the picture so I can see what I have. So the big triangle, we have 30 centimetres, and the area is what we're finding. And then the small triangle, we have 24 centimetres for this height, and the area of this was 400 centimetres squared. So we're looking for the large area, so we're going to do enlargement scale factor. Our sides that correspond, we have the 24 and the 30. So for enlargement scale factor, it's the larger one on top, so 30 over 24. And that simplifies down to 5 over 4. Then we have to do our area scale factor. So for area scale factor, we're going to square that 5 over 4. So 5 over 4 squared. So 5 squared is 25 and 4 squared is 16. So our area scale factor is 25 over 16. We then just have to find the large area. So area equals, so it would 25 over 16 times the area of the smaller shape, so times 400. That is going to give us an answer of 625 centimetres squared. Now the question was asking for the area of the blue section, so we have to finish the question fully. So the blue area, what we would do is we would take the area of the full big triangle, 625, and we would subtract the area of the red triangle, which is 400. So that's going to leave the blue area as 225 centimetres squared. So the marks for this question are awarded as follows. Your first mark is for finding your length scale factor. So either the 30 over 24 or the 5 over 4, either one of those would be accepted, okay? If this was a non-calculator question, you would be looking to simplify the fraction down, because that will be easier for you to go on and then square and multiply by values. Because this is a calculator question, 30 over 24 is fine, because you're going to type that into your calculator. So you don't have to simplify, but it's good practice just to simplify it if you can, and especially if it's a non-calculator question. Mark 2 is for squaring your length scale factor and multiplying by the area of the small shape. So the 25 over 16 times 400, that's your second mark. Your third mark is for finding that large area, 625. And your fourth mark here is for subtracting away the 400 to get 225 as just the blue area. So let's have a look now at a second past paper question. So here we have another one. This question was from 2018, paper 2, and this was question 18 in the exam, just if anybody's interested. So here we have two popcorn containers in different sizes. The small one has a height of 16, the large one has a height of 24, and then you're told here in the written section underneath the pictures that the small carton, the height is 16 and the volume is 576 centimetres cubed, and the large one is height of 24 and the volume is 1125 centimetres cubed. So the first part of this question is to show that these two cartons are not similar. So you're trying to prove that these are not similar shapes. So there's various strategies of how you could go around solving this question. You could really do a variety of things. I'm going to go for checking one of the volumes. So what I'm going to do is I'm going to check the large volume. I'm going to calculate the volume myself and see if it is 1125 centimetres cubed for that large one. And then if it is, they would be similar shapes. Obviously, if it's not, then they're not similar shapes. So let's go ahead and do that, and then I'll talk you through the other kind of options for the strategies that you could use to solve this question. So let's start off with our enlargement scale factor first of all. So obviously the lengths that correspond together are the 16 and the 24. So for enlargement scale factor, it's the larger one on top, so 24 over 16. That would simplify down to 3 over 2. So then I'm going to do my volume scale factor. So I would take my 3 over 2 and I would cube that value. So 3 cubed is 3 times 3 times 3, so that's 27. 2 cubed is 2 times 2 times 2, so that's 8. So my volume scale factor is 27 over 8. So then to find my large volume, I would be doing 27 over 8 times the volume of that smaller shape, so 576. And that's going to give me a volume of 1944 centimetres cubed. Now, what we can see here is obviously that's not the volume that was given in that written section 1125. So then all I have to do is communicate my answers and, show that that is not a similar pair of shapes. So something just as simple as since 1125 is not equal to 1944, these cartons are not similar. And that would be absolutely fine for your communication. As long as you use your answer and compare it to the question, then that would be fine. So the marks here is 3 marks. We would get 1 mark for finding our length scale factor, 1 mark for doing the cubed scale factor, so the 27 over 8 times the volume, so 576. And then my 3rd mark would be for my communication, so showing that the 2 answers are not the same and stating that they're not similar shapes. So there are alternative strategies here. So I have gone for finding the large volume and then comparing it. You could also do the small volume. So you could find the small volume and compare that to the question and see if they match. The other option is that you could use your 2 volumes and you could check the heights. So you could use your volumes, do your volume scale factor, cube root that, and then use that to check one of the heights. So you could go down that road of using those instead. So there are various options for this question as long as you are kind of checking one of these dimensions. So whether it's one of the heights or one of the volumes, you would get your marks, whatever option you decide to go for. So there is a part B to this question, if I can just scroll down here. So part B is that the large carton is redesigned so that the 2 cartons are now similar shapes. So you're told the volume of the large redesigned carton is now 1,500 centimetres cubed. We want to calculate the depth of the new newly designed large carton. So what we have here is we know the volume of the new large carton and we know the volume of the original smaller one. So we would need to use the 2 volumes to work out what the scale factor now is, and then we can multiply that by the height of the small one to find the height or the depth of the large new carton. So the first thing we're going to do is our volume scale factor. So because we're looking for the new depth of the large container, we're going to do the large volume on the top, so 1,500, and then the smaller volume was 576. So when we simplify that down, we actually get 125 when we just simplify this fraction over 48. So then to get our enlargement scale factor, because remember we're looking for the depth of the large carton, we would cube root that value. So we would do the cube root of 125 over 48. Now this gives you a big long continuous decimal answer on the calculator. So I'm just gonna I'm going to write the decimal here, 1.3758, and it carries on. But in your calculation, you could just actually type that onto your calculator. So when you do the depth you could write that decimal number, but you could actually just type that so that you get the most accurate answer possible. So you could just type cube root of 125 over 48 times the height of the smaller carton, so that was 16, and that'll give you the most accurate answer possible. So you end up with 22 centimetres. If you round your answer correctly, you'll get 22. So it's 2 marks for this question. 1 mark is for finding your volume scale factor, and then it's 1 for doing the calculation to find the new height. Okay, so what I would like you to do for this lesson is in the Unit 4 booklet, page 24, and there are only 4 questions in the booklet for similarity past paper questions, so I'd just like you to have a go at all 4 of those questions, okay? So it's on page 24. If you need any help, I will be online on the live call if you want to come on and ask me any questions, and please do, because these questions are quite wordy. So if you don't understand exactly what you're being asked to do, or any part of the question, please come on and just ask me for the help, and I will be there if you need me. Okay, thanks for listening, guys, and I will speak to you soon. Bye.